Virtual reality as a learning technology has been indicated numerous times to be an evident improvement over conventional learning methods. Our goal was to analyze the didactic and design factors for an effective use of VR for basic vocational training. The learners must be able to correctly perform a test on a basic electrical installation and respond to any faults in the system. Our working hypothesis is that immersion is an enabler for an additional sustainable learning effect. The didactic concept used was scaffolding. This means that help is provided to an extent that learners are challenged but not overwhelmed. As soon as the learner can work independently on a particular subtask, help is gradually removed again, thus it being offered drop by drop. The approach is put into effect via granular help messages and a sequence of subtasks visualizing the milestones of a measurement. In case the learner is at loss, they can get assistance from the help screen via task-specific hints or by looking at the work order. The help system emulates a chat that allows the apprentice to get further instructions from a virtual tutor. In case the button "I need help" is pressed, a chat message appears explaining the next step. Another important aspect for us was the opportunity to intertwine theory and practical action. In a vocational school, learning can be facilitated by a professional trained in vocational didactics and can occur in a setting that is learning oriented rather than production oriented. In our case, learners receive selective theory input in the VR environment during measurements and testing to relate classroom knowledge to hands-on experience. This is put into effect through theory quiz questions accessible via the help dashboard. To increase the user's motivation, we applied game design elements, milestones, visible status, and leaderboard. Learners should be motivated to complete a measurement fully and correctly, and to repeat measurements even if they have already completed them. This is put into effect through a system of awards based on a certain success criteria, such as completed measurements and the successful repetitions of a measurement. Learners should be able to track their performance across sessions and thus retain their progress regarding measurements. The feedback from apprentices as well as instructors is encouraging but also reveals initial assessments concerning the added value. Learners and trainers from the field do not regard the VR application as a substitute for practical real-life training. However, they clearly see the value of VR as an additional tool that accelerates learning, reinforces routines, and most importantly is equally accessible to all learners. From a technical point of view, the haptics are a weak point, as the standard peripheral hardware haptic feedback is limited to a vibration of the controllers. Regarding future development, the extension of certain features is taken into consideration, namely the possibility to perform additional measurements. Finally, the application will undergo modifications to be used in the vocational training of electricians in Tanzania.